Okay, so this is the next worksheet on multiple charged cations, so they variable charges, right? We're gonna have to worry about the Roman numeral stuff essentially. So first one, copper fluoride. Well, fluorine is a -1, right? Copper is a +1, right? Because I have one copper. They have to balance. So this is going to be copper 1 fluoride, right? Got to balance the charges. Copper has to be a +1. This is CuF2. So this is 1 - for fluorine, but there's two of them, right? So this copper has to be a +2. Right? I have to balance out the charges, and there's only one copper. Right? If I made the first one copper 2, then I'd have a positive charge. So this is copper 2 fluoride. Cr2O3. Oxygen is always a 2-. Oops. I'm gonna delete these so I have some space. Oxygen is always a 2-. I have 3 of them. Right, so that's a 6-. I have 2 chromiums. So what charge do they have to be? They got to be a +3 to get to a 6+. If I made it +2, I would be short on charge, right? I'd have negative charge. It'd be 4+ and 6-. So we get 3, and then this ends up being chromium 3 oxide. Next, we have PbI2. So I2 is again 1-. Therefore, we have 2 of them. Lead has to be a +2, right, to balance out. So this is lead 2 iodide. Next one, again, same kind of thing. So this one is lead 4 fluoride. Chlorine is a -1. Lead has to balance it out, and there's only 1, so this has to be lead 4 fluoride. Now, similarly, right, so this one, this chromium, CrO3, oxygen is a 2-. Chromium has to balance out. I only have 1 this time, though. So this has a total charge of 6-. Therefore, I need a charge of 6+ for chromium. So this is chromium 6 oxide. 7 is AuBr. This is gold. So Au is gold. Br is always a -1. Therefore, gold has to be 1 because I have 1 gold. So this is gold 1 bromide. Next is nickel oxide, where oxygen is always a 2-. So the nickel has to be 2. Nickel 2 oxide. Right? Nickel has to balance out. Next, we have Vi3. So these vanadium. So iodine is always a 1-. We have 3. Right? So this is a total charge of 3-. I need my vanadium to balance out, and I have 1, so it has to be a 3+. So this is vanadium 3 iodide. Just remember, right, the Roman numeral means the charge of the metal, positive charge. Last but not least, we got SnO2. So oxygen is always a 2-. right? So this is a total of 4 minus. Therefore, tin, which is Sn, has to be 4 plus because I have 1. So this is tin 4 oxide. And that's it. Moving down over to 11, it says manganese 7 oxide. So let's write out the ions first. Okay, so I have an Mn7 plus and an O2 minus. We're going to follow the same rule like I said before. Find the least common multiple, right? And then we'll get the total charges to be the same. So the least common multiple here is 14, right? 7 times 2. 2 doesn't go into anything else. 7's an odd number. So the least common multiple is 14, so I need this charge to be 14. I'm going to put a 2 here. I need 2 manganeses to hit 14. 14 plus, and I need 7 oxygens to hit 14 minus for this to cancel out. Therefore, this is going to be Mn2, there's 2 of them, O7, right? To cancel out these charges appropriately. Next, we have niobium 5 fluoride. So niobium is Nb, that's a 5 plus. Chlorine is a 1 minus, right? The least common multiple is 5, right? So I need 5 chlorines. So NbCl5, right? I can keep the niobium to stay the same. Next, I have titanium 3 phosphide, right? So titanium is a 3 plus, phosphide is a 3 minus. I just need 1 of each. So this is just TIP, tip. Next is 14 palladium 4 sulfide. So this is PD 4 plus. Sulfide is a 2 minus. I need these to cancel out, right? Least common multiple is 4. I need 2 sulfurs. This is PdS2. Next, we have platinum 2 fluoride. So platinum is a 2 plus. Oops, PT. And then fluoride is a 1 minus, right? The least common multiple is 2. So platinum, fluoride, so PTF2, right, to balance those out. A common kind of trick people do is they take these charges like this, Mn7 plus and O2 minus, and they just swap them like that. So this is Mn2, O7. Now you have to be careful, right? Because if you do use this and you get something that is like that's reducible, you're gonna be wrong. You'll get the wrong answer. So example is this palladium. Right? This is a PD4 plus and a sulfur 2 minus. If I just swap these, I get PD2 S4. That's not the least common. I can get rid of 1 of each of these. Sorry, divide these both by 2 essentially. Right. So if I divide these by 2, then I get that. Right? They're both divisible by 2. So you can do the swap if you want. I think it's just easier to stay consistent and make sure you don't make a mistake, right? Don't. And then you don't notice that something is reducible and then get an answer wrong. So it's up to you. Right? I do it the way that I'm doing it right now. The way I was doing it before that I'm going to continue doing. So You want to understand why that is, not just kind of have a mechanical way to do it. Next, we have osmium 3 oxide. So osmium is a 3 plus, oxygen is a 2 minus. Osmium and oxygen, there's a 3 and a 2, right? The least common multiple is a 6. So I need 2 osmiums and 3 oxygens, right? You can do the swap here and you wouldn't have a problem. Sometimes you will if you did that. Iridium 4 nitride. So iridium is IR, that's a 4 plus. Nitrogen is a 3 minus. The least common multiple is 12 this time. So to get plus 12 for iridium, I need 3 of them, IR3. And then I need 4 nitrogens, right? You can do the swap thing here too if you want. So 3 iridiums and 4 nitrogens. Next is cobalt 2 chloride. So to balance this out, I need 1 cobalt and 2 chlorides. Oops. And that's it. So you could do the swap thing here, right? You can do the swap thing for a lot of things, but you have to be careful if you get something like PDS4, because you will get the answer wrong. That's not correct. So just be aware of that. Iron 3 sulfide, 19. So this is Fe3 plus. Sulfide is a 2 minus, right? You could do the swap thing here. I'm going to phrase it as the way I normally do. You need the least common multiple of charges, right? So Fe is going to be, you need 6 plus from Fe, and then you need 6 minus from sulfur. So I'm going to have 2 irons and 3 sulfurs. Last, we have gold iodide. So we have Au3 plus from gold 3, and then iodine is the 1 minus. And do the swap thing if you want again, right? This is gold 1. We have 1 here. Or sorry, gold 3, but we have 1 gold here. So the 1 subscript, and then I3. So that's it for this one. Hope that helped, and I will see you in the next worksheet.